Hey guys, congratulations. We have officially finished Chapter 5 of College Trig. So today, our time together is just going to be to go ahead and go back and just do some practice questions from 5.1 all the way through 5.5. I just want to make sure that we hit those key areas that you will see on the test tomorrow. One thing before we get started, I want you to know that you do get to use this cheat sheet. There was a cheat sheet in your packet. If something happened to it or you happen to have misplaced it, there is an electronic copy of this in our Google Classroom. So please do make sure that you have this available to you, because throughout the test you will be using every single area of this sheet. And without further ado, let's go for it, guys. We're going to go all the way back to 5.1, okay? Now 5.1 is where they gave you information. Like here they tell you the secant of u is negative 3/2 and the tangent of u is greater than 0, okay? This was the very first thing that we did with our distance learning. And you had to be able to first figure out what quadrant your triangle would fall into. So the secant is the reciprocal of the cosine. When you look at reciprocals, all that does is it flips the fraction upside down. It does not change the sign. So if our secant is negative, then our cosine is negative. This tells us the tangent of u is greater than 0. So that means our tangent is positive. So your first step for this very first question, you would have to figure out what quadrant is going to the left, because cosine is left and right, so I know it has to be quadrant 2 or 3. Out of those two, where would the tangent y divided by x be positive? And the answer would be quadrant 3. And the reason why is because in quadrant 3, both the sine and the cosine are negative, and negative divided by a negative gets you to a positive. Okay, so step 1, we're going to go ahead and draw our triangle. Our terminal side is in quadrant 3. Remember, you always have your triangle with the terminal side and the x-axis. 100% of the time it has to be with the x-axis, not the y. We have u. Okay, so u is the angle that we're focused on. It will always be right next to the origin. Again, 100% of the time, there will never be an exception to that rule. Okay, now I have the secant. The secant, again, is the reciprocal of the cosine. The cosine is the adjacent over the hypotenuse. So the secant, because it's the reciprocal, that is the hypotenuse over the adjacent. So when I look at this, I have negative 3/2. So I know one of the values has to be negative because I have two values being divided and the outcome is negative. Your hypotenuse will always be positive, 100% of the time. So the 3 is positive. The adjacent is a 2, and I know that it's negative because from the origin you're traveling to the left. That's the negative direction. So again, that's just one thing to be really careful of. When you're figuring out if your signs are positive or negative, you really have to make sure that you're careful looking from the origin. Are you going left or right, and are you going up or down? Now, before we find all 6 trig ratios, we do have to find the opposite. So here I need to use the Pythagorean theorem. So I take the two sides, the two legs that create the 90-degree angle. Pythagorean theorem. So negative 2 squared plus b squared equals our hypotenuse squared. Negative 2 squared, negative 2 times negative 2 is a positive 4. 3 squared, 3 times 3 is 9. Minus 4 to the other side. 5, I would end up with a 5 because 9 minus 4 is 5. Now here, I am canceling a power of 2. In mathematics, anytime you cancel a power of 2, you do have to include both the positive and the negative. Obviously, when I'm looking at a triangle, I'm not going to include both. I have to look at its location and identify, okay, is it a positive square root of 5 or is it a negative square root of 5? From the x-axis, it's going downwards. So this is a negative square root of 5. So going to the left, that's why that is a negative 2. Traveling downwards, that's why that is a negative 5. Now it's time to go ahead and actually answer the question. They want us to find all 6 trig ratios. So I have the sine of theta. The sine is the opposite, negative square root of 5 over the hypotenuse, which is 3. Awesome. The cosecant of u, that is the reciprocal of the sine. So if I flip it upside down, I'll have negative 3 over a square root of 5. I can't leave a square root on the bottom. So for the cosecant, I have to rationalize the denominator. My marker is wearing out here. Okay, so if I rationalize the denominator, I end up with a negative. 3 times the square root of 5 is 3 square roots of 5. Square root of 5 times the square root of 5 is the square root of 25, which is just 5. So far I have the sine of u is negative square root of 5 over 3. The cosecant of u is negative 3 square roots of 5 over 5. Now the cosine. The cosine is the adjacent over the hypotenuse, so negative 2 over 3. The secant of u is the reciprocal of the cosine, so it would be negative 3 over 2. You just flip that fraction upside down. Tangent of u. Tangent is opposite over adjacent, so negative square root of 5 over a negative 2. Negative over a negative becomes a positive, square root of 5 over 2. Your cotangent is the reciprocal of the tangent. The tangent is a square root of 5 over 2, so if I flip it upside down, it's 2 over the square root of 5. Rationalize the denominator, so I have 2 square roots of 5 over 5, and that was our very first idea from chapter 5. Okay, I hope that makes sense, and then we're going to go ahead. The next part, we were verifying. So on your cheat sheet, when we are verifying, what we're doing is staying within this area. These are things like our reciprocals and being able to write tangent and cotangent as fractions. So that quotient identities, our Pythagorean identities, even and odd cofunctions, okay? So remember when you are verifying, what you want to do is take the more complex side. So I'm going to take the sine of x plus the cosine of x times the cotangent of x. I need to work with this side until it equals the cosecant of x. I need this to match this. One of the tips that I gave you way back when we were in 5.1 is it is a little bit easier if you can turn everything into sines and cosines. And so what I would do here, I have a sine of x plus a cosine of x. But cotangent, what I'm doing is I'm going to go ahead and use that quotient identity. Cotangent, I can write it as a cosine of x over a sine of x. So now it's all in sines and cosines. This is like a fraction, right? I can take top times top, bottom times bottom. So I have sine of x plus cosine times a cosine is a cosine squared of x. 1 times sine is a sine of x. Now they want us to add, but if I'm adding fractions, you have to have a common denominator. This is the sine of x over 1. So I have to multiply top and bottom by the sine of x. The sine of x times the sine of x is the sine squared of x over 1 times the sine of x is the sine of x. I'm adding that to the cosine squared of x over sine of x. Now here, common denominator stays. So my sine of x just carries on to the bottom. Sine squared of x plus cosine squared of x, there's your Pythagorean identity. Sine squared of x plus cosine squared of x equals 1. 1 over a sine of x. What this means is, what is the reciprocal of the sine? That is the cosecant of x. You just did a proof and you verified. Super fun. Okay, the next one. If they give you a problem like this, what you want to do first is FOIL. So that was kind of a cool day, is when we got to see that, hey, you can FOIL trig functions. So when I'm FOILing, first times first, secant of x times a cosecant of x, you guys, you can't do anything besides put the two next to each other. So it is a secant of x times a cosecant of x. Outside plus secant of x times 1 is a secant of x. Inside minus tangent of x times the cosecant of x. Last, minus tangent of x. Okay, so this is where I'm at. I'm going to go ahead and cover up some of that other stuff so it doesn't all get mumble jumbled. All right, so I FOILed. First, outside, inside, last. I have 4 terms. I need to keep going with this until I can prove that this whole thing is just a simple cotangent. That's all that it is. So again, my first step is I don't want to deal with all of these different things. It's much easier if you go to just sines and cosines. Secant is 1 over a cosine. Cosecant is 1 over a sine. Secant is 1 over a cosine. Tangent is sine over a cosine. Cosecant is 1 over the sine. Tangent is sine over the cosine. So that was my next step. So step 1, I went ahead and I FOILed. Step 2, I turned everything into terms that only contain sines and cosines. Now when I look at this, one of the first things that I noticed when I was writing these is I could cross cancel the sine of x because there's 1 on the top, 1 on the bottom. That would leave me with 1 over a cosine. So I have a positive 1 over a cosine minus 1 over a cosine. So these two things can totally eliminate themselves. So sine of x, cross-canceled sine of x, leaving you 1 over a cosine of x. 1 over a cosine of x minus 1 over a cosine of x is 0, so the middle is gone. So what I have now, top times top, bottom times bottom, because this is a product. 1 over cosine of x times the sine of x. The whole middle, that's gone. Minus sine of x over cosine of x. Now what I need to do is get a common denominator. You can't eliminate a portion. So I can't look and say, hey, these both have a cosine, so let's just get rid of that sine. I can't get rid of something, but I can add something. So I can multiply both top and bottom by my second fraction by sine of x. So I'd have 1 over cosine of x sine of x minus sine of x times the sine of x is the sine squared of x. Now my denominator matches, guys. Super cool, okay? Keep your common denominator. When you subtract fractions, the bottom does not change. So it's cosine of x, sine of x. The top, these are not like terms. So it's 1 minus sine squared of x, okay? So I got it to there. Now I need to prove that this is a cotangent. So I'm going to go ahead. I see that I have a sine squared. Remember when we had those sine squareds? That was kind of our little key to look for Pythagorean identities. The identity that has a sine with the power of 2 is our ever so popular sine squared of x plus cosine squared of x equals 1. Well, I have 1 minus the sine. So what happened is they took the sine function and they minused it over. That's how they got this. So if I move the sine function over here, it would no longer be there. That means 1 minus the sine squared of x is equal to cosine squared of x. So I can rewrite this cosine squared of x over cosine of x sine of x. Now that is the same thing. Cosine squared of x means cosine of x times the cosine of x. It means that you actually have 2 of them. Now on the bottom, I have a cosine and a sine. I don't know why I wrote it in a different order. It's the commutative property of multiplication, okay? It doesn't change your answer. But what I can do, because this is a 2, knowing that there's 2 of them, I can realize that this is like 2 fractions being multiplied because cosine times a cosine is cosine squared. Sine times a cosine is cosine times a sine. So now I can look at this. Cosine cancels a cosine. Cosine over the sine is the cotangent of x. You just did a proof. You verified it. Ta-da! Done. Okay. Next one. Now this one is where we had fractions, okay? I don't know if you're watching the time on the video. This one may actually maybe even take us an hour, but the last thing I want to do is not prepare you for a test. So sit back, relax, and let's just keep going, troops. Okay, if I'm looking at C, I need to take the more complex side, and I need to prove that it is really the cosecant of theta, okay? So the first thing that I notice, they want us to add fractions. Well, guys, you can't add fractions unless you have a common denominator, right? So what I have here, I have two different denominators. And again, just like the last problem, I can't eliminate a sine of theta, and I can't eliminate the 1 plus the cosine of theta. So what I have to do is create a denominator that has both pieces. It has to have the sine and 1 plus the cosine of theta. And that has to go for both fractions because you need a common denominator. But the cool thing is once you have that, that carries all the way over into your final answer. Okay, so if I am looking here, this first fraction has 1 plus the cosine of theta. It's missing the sine. So I need to multiply top and bottom by the sine of theta. Sine of theta times sine of theta is sine squared of theta. The bottom, it just created my common denominator. Now when I'm looking here, it has the sine. It was missing the 1 plus cosine of theta. So I need to multiply both top and bottom by 1 plus the cosine of theta. This is one term times two terms, so you have to distribute. Cosine of theta times 1 is cosine of theta. Cosine of theta times cosine of theta is cosine squared of theta. Now check this out. These are not like terms. None of them are like terms. Yes, these are both cosines, but they do not have the same exponent. So combining these would be like trying to combine x's with x squared. It cannot happen. But here's an identity, you guys. Sine squared of theta plus cosine squared of theta, 1. Super cool. Plus, the other thing I have is cosine of theta. So again, what happened? I made my common denominator. When I went to go and add the top, I noticed that I had a Pythagorean identity. Sine squared of theta plus cosine squared of theta. I could take these two together, use the identity, and say, hey, guess what? That's a 1. I still have my plus. Cosine of theta goes right here. Now check this. 1 plus cosine of theta over 1 plus cosine of theta, they would cancel. If everything cancels on the top, all you have remaining is an unwritten 1. The bottom, all I have remaining is a sine of theta. 1 over something means you take the reciprocal. So 1 over a sine, the reciprocal of the sine is cosecant. Ta-da! Done. Madison Olson, I know you're smiling. You like this. And you guys, I bet the rest of you are starting to like this more. It's probably, it's kind of been a while since we've manipulated all those different functions, but it's so stinking fun. Okay, so A, B, and C, that is just going ahead and reviewing how you verify. A big thing on the test is going to be just to make sure that you do read the directions. Okay, so if you're verifying, you want to make the more complex side match the more simpler side. Factoring, that was a skill that we learned. We can go ahead and factor trig functions using all those methods that we used in algebra. You can do multiply add method. You can do difference of squares. You can divide out greatest common factors. You can do grouping. Insane. Okay, so if this says to factor, that's all you are doing. Factor completely means you have to keep looking and say, okay, is there more I can do? If there is, you got to keep going. But all you're doing is factoring. You are not trying to find any solutions, okay? When you are factoring, step 1 is you always look to see if there's something in common to divide out. So for A, your first step would be to divide out the greatest common factor. Both of these terms contain a cotangent squared of x. If I take cotangent squared of x and I divide it by cotangent squared of x, I would have a 1. Minus cotangent squared of x, I took it on the outside, I just have cosine squared of x left. So step 1, I went ahead, I divided out the greatest common factor. But this says completely, meaning I get to a point where there's nothing more I can do. I can do more. 2 terms minus in between, I can take the square root of 1 and get a 1. I can take the square root of cosine squared of x and get a cosine of x. So this is the difference of squares. So my final answer, cotangent squared of x, because that's still there, that's step 1. That was your greatest common factor. When I took the square root, I have 1 plus the cosine of x, and I have 1 minus the cosine of x. Now there is nothing further I can do. This is factored completely. That's where you stop. Okay, the next problem, they are trying to trick you here. Okay, it's 1, 2, 3 terms. If you are factoring with 3 terms, it's the multiply add method. You cannot do the multiply add method unless you have the same trig function, meaning I can't have a cosecant squared and a cotangent. So there's where you're going to have to go to your cheat sheet and say, okay, if it's a power of 2, it's a Pythagorean identity. Where do I have a cosecant squared of x? Well, right here. Cosecant squared of x can be replaced with 1 plus a cotangent squared. So I can change this to 1 plus a cotangent squared of x. Now it's only cotangent, so cosecant squared of x by the Pythagorean identity is 1 plus cotangent squared of x. I still have minus cotangent of x minus 3. Now I have 1, 2, 3, 4 terms, but I can combine like terms. But what I want you to realize here is I'm going to be doing multiply add method. So you have to have it in standard form. So my exponent of 2 needs to come first. So cotangent squared of x minus cotangent of x, positive 1 minus 3 is a negative 2. 1, 2, 3 terms with the same trig function, multiply add method. There is not a number in the front, so it's just the basics. What multiplies to the last term, which is a negative 2, adds to the middle term, which is a negative 1. That is a negative 2, positive 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. Because there's not a number in the front, your answer is just a cotangent of x with these values. So cotangent of x minus 2 and cotangent of x plus 1. It's a minus 2 because the 2 was negative, a plus 1 because the 1 was positive. Moving right along. Okay, 2 terms with the minus in between. Let's square root these puppies. If I take the square root of a secant to the power of 4, I get a secant squared of x. And this the square root of 16 is 4. So by the difference of squares, this is the secant squared of x plus 4 and the secant squared of x minus 4. Okay, so I did the difference of squares, but guys, you're not done. And that's where they try to trick you. At this level in math, just because you did one method doesn't mean that you're done. You always have to look. I can do the difference of squares again because I have 2 terms minus in between. Square root the first term, square root the last term. The square root of a secant squared of x is a secant of x. Square root of 4 is 2. Now this one I cannot because it's a plus sign. That method is called the difference of squares, meaning it only works if it's a minus. We have a plus. Okay, so this is secant squared of x plus 4 because I could not change it. It carries on into my final answer. Now I take the secant of x and 2 and I add them and I subtract them, and this would be your final answer by factoring. So far we have reviewed 5.1. Put on the seatbelts, quick turn. 5.2. Now here's the deal with 5.2. Very, very similar to 5.1. In fact, I'm not even quite sure. I don't know why they gave us a whole nother section to verify, because in 5.1 they taught us how to do that. So I did only put 3 questions just to give us more practice because this was a little bit tricky. Okay, and in 5.2 they just stepped up the difficulty. But if you are verifying, you want this side to match this side. Now, one of the tricks, and guys, I did not realize this until right now, okay? So I went through all this work because remember, I always practice ahead of time. The bottom is a monomial. If the bottom is one term, you can take each term from the top and put it over the bottom. So, oh my gosh, I did this the long way. But remember, there is many ways to do each of these problems. Let's review the easy way. I could take a secant squared of theta over a secant squared of theta minus, because it's a minus sign in the problem, 1 over a secant squared of theta. Now, secant squared of theta over secant squared of theta, you guys, that's a 1. If you divide something by itself, it's a 1 minus 1 over a secant. If you have 1 over something, what they're telling you is, hey, flip it over, do the reciprocal. The reciprocal of a secant squared is a cosine squared of theta. So here's my Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. we have 1 minus a cosine. So that means they took the cosine and they moved it over here. So if I have cosine squared of theta here, what I have is equal to a sine squared of theta, which is verified. Okay, if you want to do things the hard way, what I did is I used Pythagorean identities to change secant squared of theta minus 1 into a tangent. Then I had a fraction over a fraction. I had to skip, flip, multiply. But again, this is good to show you because even after doing this for years, I just did this like an hour ago and I did one method. Now while I'm recording, I'm like, whoa, there's a whole new method. Okay, so as I'm going ahead and reviewing with you, if you see a different method that you want to go for and try it, please do. Okay, there's not one right way to do this. All right, and we're going to keep going. Anytime you have two binomials, I think the easiest thing to do is to go ahead and FOIL them. Okay, so that's what I'm going to go ahead and do. So if I take tangent squared of x times cosine squared of x, outside minus tangent squared of x, inside plus cosine squared of x, positive 1 and a negative 1 is a negative 1. Now when I look at this, tangent is sine over cosine. And so this is really cool, you guys, because if you go ahead and look, so I'm going to go sine of x over cosine squared of x. I can't talk and write at the same time. I'm going to start writing crazy things. Okay, so what I did is I took tangent squared of x. Tangent is sine over cosine. This was already a cosine. It's being multiplied by your tangent. Tangent is sine over cosine. Cosine is already a cosine and 1. It's great the way that it is. Now this is a product. So you're multiplying a cosine squared of x, and that's what the denominator is. Boom! Sine squared of x minus, now I have sine squared of x over cosine squared of x plus, oh you guys, this is good, cosine squared of x minus 1. Okay, remember you have that property, commutative property. If you're adding, you can move the order. So I'm adding a cosine squared of x. I can add it over here. So this means I can have sine squared of x plus cosine squared of x. We know this, sine squared of x plus cosine squared of x, that's a 1. So I can put those two, add them together to get a 1. Then I have minus sine squared of x over cosine squared of x minus 1. Check this. Positive 1 minus 1, they are like terms. When I go to add them together, positive 1 minus 1 cancels. So what I have left is a negative sine squared of x over a cosine squared of x. Negative sine over cosine is tangent. They are both squared, so it's negative tangent over x. Boom! I am having a great time. I hope you guys are too. This is so stinking fun. Okay, number 3, and then we are done with 5.2. I want this side to become this side. And guys, this is where they gave us the whole idea of conjugates. They're like, hey, guess what? You had conjugates in Algebra 2, and you had conjugates in college algebra, and now that you're in college trig, we're going to do it again. In order to cancel a trig function on the bottom, okay, if I'm trying to simplify this and I have 1 minus the sine of x, what we want to do is multiply both top and bottom by the conjugate of the bottom. And just as a review, conjugate means you keep the first term the same, the last term the same. What you have to do is change the sign in the middle. Now on the top, it is distributing. Cosine of x times 1 is a cosine of x plus cosine of x times a sine of x, cosine of x times the sine of x. Bottom. 1 times 1 is 1. And I'm going to do it right here because I know when I multiply by conjugates, things are going to be able to cross off. Okay, so 1 times 1 is 1. 1 times the sine of x is a sine of x. Negative sine of x times 1 is a negative sine of x. Positive times a negative is a negative. Sine of x times sine of x is sine squared of x. Boom, boom. Look at this. 1 minus sine squared of x. Sine squared of x plus cosine squared of x equals 1. Okay, so I'm noticing right away I have a 1 and I have a sine squared of x. I can simplify this thing by knowing my property. What we have here is 1 minus the sine. So that means I took that sine and I moved it to the other side by subtracting. That means that this has the same value as a cosine squared of x. This is a monomial on the bottom. What that means is I have a fraction with one term on the bottom. So I can separate it. So this is a fraction. There will be a plus sign in between. This is a fraction. Okay, so I'm going to go ahead right down here and write that. So I have a cosine of x over cosine squared of x plus I have a cosine of x times a sine of x over a cosine squared of x. Now remember, cosine squared of x means you have the cosine of x 2 times. Okay, that's what this means. So when I go to cancel things, because that's what we're going to do here, 1 cosine of x will cancel 1. I still have a cosine of x on the bottom. When everything cancels off the top, it would be a 1. Well, 1 over a cosine, when it's 1 over something, it means do the reciprocal. The reciprocal of a cosine is a secant, plus sign. Cosine cancels a cosine. So what I have left is sine over cosine. Sine over cosine, by definition, is a tangent. You just verified and we just finished 5.2. Give yourselves a pat on the back. Give yourself an air high five. Great job. Moving on to 5.3. Now 5.3, this is where we were solving equations and I started losing a lot of you guys on the Zoom call because you thought it was easy. So that is awesome. Okay, so as we're reviewing, hopefully I can get through this a little bit quicker so it doesn't take so long. When you are solving a trig equation, they're telling you that you're using the domain of 0 to 2 pi. That means you're going to find all of the answers that fall within the unit circle. Exact form means do not use decimals. Keep everything as a square root. In order to do this, you need to isolate your trig function. So what I'd have to do here, I can't have sine functions on both sides. So step 1, I have to add the sine of x to the side. 1 sine of x plus 1 sine of x is 2 sines of x, plus a square root of 2. Everything canceled here, so now I have a 0. Okay, next step, I would minus the square root of 2 over. So 2 sine of x equals a negative square root of 2. Last step, divide by 2. So sine of x equals negative square root of 2 over 2. Now this is something I can go into the unit circle. The sine is the y value. So I'm looking to see where is the y value equal to a negative square root of 2 over 2. Well, y value negative square root of 2 over 2, that's at 7 pi over 4. So x equals 7 pi over 4. That's a solution. Let's keep looking. Y value negative square root of 2 over 2. That is 5 pi over 4. And we are done. So you solve, you isolate your trig function, go to the unit circle, find all the answers that fall between 0 and 2 pi. Okay, the next one. If you see a power of 2, chances are you're going to have to factor, okay? So I do have just sine functions. There's 1, 2, 3 terms. So this is the multiply add method. There is a number in the front. So first term times last term. 2 times negative 1 is negative 2. Middle is negative 1. So I have to find 2 numbers that multiply to negative 2 and add to negative 1. So that's negative 2, positive 1. That's going to replace the middle because of that number in the front. So I have 2 times the sine squared of x. The middle term had just a single sign. So it's minus 2 times the sine of x plus 1 times the sine of x minus 1 equals 0. So notice the negative 2 and plus 1 are right there in the middle. They replace that middle term. Now I have 4 terms. So now we get to do the grouping method. I can divide out 2 sine of x. So 2 sine of x goes to the outside. The 2 is gone. I had 2 sines. I took 1 out. I'm down to 1. Minus 2 sine of x divided by 2 sine of x. That's a 1. Plus, hey, sine of x minus 1. This matches. So all I have to do is take out a 1. But you do have to take something out. Otherwise, you're not officially doing the grouping method. You have to take something out of each group. Whatever you took out, that forms a group. So I took out a 2 sine of an x and then I took out a positive 1. What they have in common, the sine of x minus 1, that is a group. Now to find your answers, you have to take each factor, so each set of parentheses, and set it equal to 0 separately. So it's going to look like this. 2 sine of x plus 1, that equals 0. Sine of x minus 1, that equals 0. Now if I'm solving for the sine of x, here I'd have to minus 1 divided by 2. So sine of x would equal negative 1 over 2. Here I'd have to add 1. So the sine of x would equal 1. Both of these things are ready to go ahead and look at the unit circle. So the sine is the y value. Where is my y value in negative 1/2? Well, y, if I'm looking for a negative, that means I'm going down below the x-axis. Negative 1/2 is at 11 pi over 6. So I have 11 pi over 6. There's an answer. Negative 1/2 in the y location. 7 pi over 6. Okay, there's my solutions. When is the sine a 1? Where is the y value a 1? There's only one location, and that's at pi over 2. And you're done. And one thing I'm hoping that you notice is every question is totally different, okay? I'm trying to make sure that I do review everything from this chapter with you. Okay, now Houston, we have a problem, okay? Cosine of x plus 1 equals the sine of x. Okay, now we can't go to the unit circle like this because we're looking for cosines and sines. So what we have to do is somehow convert it into just sines and cosines. Well, I know I can do that using Pythagorean identities, but they always have a power of 2. So what we're going to do is go ahead and multiply both sides, or I'm going to go ahead and square both sides, okay? So I noticed that I have cosines and sines. I need to use Pythagorean identity. They have to have powers of 2. So step 1, you square each side. What you do to one side of an equation, you always do to the other. Because this is a power of 2 on a binomial, you are going to end up foiling this side. This ends up being sine squared of x. Cosine of x times cosine of x. Cosine squared of x. Cosine of x times 1. Cosine of x. 1 times cosine of x. Cosine of x. 1 times 1 is 1. So I can combine my two like terms. Cosine squared of x plus cosine of x plus cosine of x is 2 cosine of x plus 1 equals sine squared of x. Okay, so now you might be thinking, yeah, great job, Becker. We still have sines and cosines and we just did a crap ton of work. Okay, yeah, I understand that. But now that this has a power of 2, I can use my sine squared of x plus cosine squared of x equals 1. And if I isolate this, meaning I'm going to take this cosine squared of x and minus it over, I can change my sine squared of x to 1 minus cosine squared of x. Okay, so I still have this side, cosine squared of x plus 2 times the cosine of x plus 1. Now what I have to do is get it set equal to 0. So I'm going to minus the 1 to the side. Hey, cancels, cancels. Awesome. If I add a cosine squared of x, add a cosine squared of x. Remember, you can only add like terms. Cosine squared of x plus cosine squared of x, that's 2 cosine squared of x. I still have a plus 2 cosine of x. The ones canceled, I moved everything here so it's a 0. There's a power of 2. Very strong indicator that you should definitely check for factoring. I can factor this. Okay, what I can do here is take out their greatest common factor. I can take out a 2 and a cosine of x. If I take that out, this had 2 cosines, so I'd still have 1 cosine left. 2 cosine of x divided by 2 cosine of x equals 1. Now you take each factor. So whatever I divided out, which was 2 cosine of x, you said that equal to 0. What you have left, cosine of x plus 1, you set that equal to 0. Now I need to solve for the cosine. So if I divide by 2, 0 divided by 2 is 0. I can go to the unit circle with that. Minus 1. So the cosine of x equals negative 1. Now these are not your solutions. These get you your solutions because these equations are ready for the unit circle. You need to know that a cosine means the x value. So on the unit circle, where is x equal to 0? At pi over 2 and 3 pi over 2. Okay, so x equals pi over 2 and x equals 3 pi over 2. Now, where does the x value equal negative 1? Well, the x value equals negative 1, only one location on the unit circle. That is at pi. So here are your 3 solutions. pi over 2, 3 pi over 2, and pi. Hope you're enjoying yourself. We got a couple more. Okay, now this is called a multiple angle. So remember back in 5.3, we were not dealing with double angles, half angles, none of those things. You still isolate your cosine. So in this case, we are isolating the cosine of 3t. And then we just have to take the location from the unit circle and say 3t equals that spot. So step 1, I have to add the 1 over. So 2 times the cosine of 3t equals 1. Divide the 2 over. So cosine of 3t equals 1/2. I go to the unit circle at this point, and I find where the cosine is equal to 1/2. But instead of saying that t equals that, it's 3t. So cosine, the x value is 1/2 at pi over 3. There's another one, 3t, and I got it from right here. Where does the cosine, the x value, equal 1/2? 5 pi over 3. Okay, so now what I have to do is solve for t, because when you solve, it always means to get the letter or theta by itself. T is not isolated, so I typically would divide by 3, but you can't divide fractions. So what I'm doing is I'm multiplying by the reciprocal, because 1/3 of 3, this would become just 1t, top times top, bottom times bottom, so one answer is pi over 9. Same thing here. You can't divide by 3 because you can't divide fractions. So I'm going to multiply by the reciprocal instead. 1/3 times 3 is 1t, top times top, 5 pi, 3 times 3 is 9. There are your two solutions. I gave you one more similar to this. It's x over 2. You still do the same thing, you guys. What we have to do is find the spots on the unit circle that match whatever we get if we isolate tangent of x over 2. So I want tangent of x over 2 by itself. So I would have to minus the 3 over, right? So this would become a -3. Then you would divide by 3. -3 divided by 3 is a -1. So it's x over 2 equals, on your unit circle, where is the y divided by the x equal to -1? Well, right here, they're both square root of 2 over 2. One's positive, one's negative. So if you divide it, you get -1. So one location is 3 pi over 4. There's one. There is another one. And again, I'm putting x over 2 because that's what I have here. Where else? We are going to look in quadrant 4. They're both square root of 2 over 2, but one's positive, one's negative. So that's 7 pi over 4. Again, just like the last problem, I can't divide by 2, or sorry, you wouldn't divide by 2 anyway. Here you're going to multiply because you want to cancel that denominator. So both of these I have to multiply by 2. Cool thing is you can cross cancel. So you could either do top times top, bottom times bottom, and then you could go ahead and simplify. Or I could say, okay, I canceled both of the 2, so x equals, this 2 could be divided by 2. It would be a 1. This would be a 2. So I'd have 3 pi over 2. Okay, this one I'm going to go ahead and do top times top, bottom times bottom, just in case some of you are like, what? So if I multiply a 2, it's the same thing as 2 over 1. So the other way you could do this, besides cross-canceling, top times top, 7 pi times 2, that's 14 pi. 4 times 1 is 4. Now you would just have to reduce because you can divide both top and bottom by 2, and you'd have 7 pi over 2. So however you want to do that, whether you cross-cancel or take top times top, bottom times bottom. And that is it for 5.3. And guys, just because this video is getting close to 45 minutes, what I am going to do is stop it here and just go to part 1 and part 2 because I don't want it to take a really long time to load or have something happen where you don't get the whole video. So I'm going to go ahead, hit pause, go grab a snack, come back, and we will review the last 2 sections together.